Hi there, welcome to today. We're going to talk about specific heat today. So first I got a question for you. Let's say you are going to the beach. So put in the poll, the first thing you do when you go to the beach, what is it? Do you play in the sand? Do you jump in the waves? Lay on the beach with a good book? Got beach volleyball? Or are you a person who likes to go fishing? What do you like to do? I might give a moment to kind of answer that, see what we get. Here we are. And so either way you decide what you're going to do. You got to get across the sand, right? You start going across the sand, and how do you feel about the sand? The first thing I'm thinking when I start going across the sand, I'm like, oh my gosh, ouch, my feet hurt, stop, ouch, 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 ouch. And you're running, 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 running. You're trying to get to the water, finally get to the water. Things are a little bit better, right? That ouch on the sand and the water, and that's due to the specific heat difference here. So let me recap kind of what specific heat is. We know specific heat, if you watch the video ahead of time, specific heat is how much heat it can take before the temperature changes. So if we think about our beach situation here, you're sitting on the beach, we know the sand is really hot on our feet. And that's because the sun is shining down on the sand and heating it up. But actually, the sun is shining down on the water too and heating that up also. It's just the fact that they have different specific heats that causes this heat up to be different. They're getting the same amount of energy, but one heats up faster than the other. That's because every substance in the world has a different specific heat. Take a look at the table here. If we pick aluminum, aluminum has a specific heat of 903 joules per kilogram times Kelvin. So what that means is if you want to heat up aluminum and you have 1 kilogram of it, you're going to have to give it 903 joules of energy to raise it 1 degree. Check out a different number though. If we take something like iron, it's about half as much. Iron takes 450 joules of energy to raise 1 kilogram 1 degree. So let's think about those two pieces underneath the sun. So if I have a piece of aluminum under the sun and I have a piece of iron under the sun, that sun is shining down with that same amount of energy. They're both laying on the beach. I'm going to be putting in so much energy in that part, but aluminum isn't going to raise its temperature unless you give it on 903 joules of energy. Then it'll raise 1 degree Celsius or 1 degree Kelvin. But iron, it doesn't take that much. It only takes 450. So if you happen to give it 903, it's going to take that 450 and it got it twice, which means that it's going to raise 2 Kelvin or 2 degrees Celsius. So over time, I can see my iron is going to get much hotter, much faster than my aluminum. And that's all because of specific heat. Let's bring us back to our beach. Man, it feels cool in the water, right? It feels beautiful. That's because of the specific heat of the water. The sand has a really low specific heat, and the water has a really high specific heat. Check out water on our table. Water is 4180. Sand is much, much lower than that. It's about 10. So if we're looking at sand of 10 and the water of 4180, there's a huge difference there. Sand is going to heat up so much faster than the water is, all due to specific heat, which again is how much heat it takes before the temperature starts to change. So let me give you a question here. Now that we've kind of learned a little bit about specific heat. So in the poll, taking a look at this graph, I have different substances, A, B, C, and D. Which substance has the highest specific heat? I give them a moment to figure that part out. And after it comes in, hopefully I can know how much or how little to talk. But I might say something like this. Okay, when I'm looking at the chart, I can see if I look at substance D, for instance, if I wanted to raise substance D 1 degree, it would take 3 joules of energy to do it. If I wanted to raise substance A, I got a different color here. If I wanted to raise substance A 1 degree, it would take only, I don't know, that might be 0.25 joules of energy for that one. So which one has the highest specific heat? The specific heat is the amount of energy you need to add to raise it 1 degree Celsius or 1 degree Kelvin. From looking at this chart, I can clearly see that D has a higher specific heat than A. Of all of the ones here, D would be the best answer because it has the most amount of energy you need to add to it before the temperature starts raising. Okay, we got to do a little math with these kind of problems. To do that, if you watch the video ahead of time, you know this MCAT thing. MCAT is kind of how we say this equation is because it really does kind of look like MCAT, MC delta T. Q stands for our heat. And if we want to calculate how much heat it needs to raise any substance by a certain degree, we're going to need its mass. We're going to be using it in kilograms, and that's because our specific heat is in kilograms. If you look back at the table, that's in kilograms too. And our change in temperature is going to be in Kelvin. Now, really, you could use it in Celsius too, because 1 degree Celsius is the same as 1 Kelvin on the scale, so you could go either way. We're going to be kind of focused in on Kelvin, though. So let's try a problem with this equation. How much heat does 32 kilograms of water absorb when it is heated from 25 degrees Celsius to 80 degrees Celsius? The specific heat of water is 4,180 joules per kilogram Kelvin. All right, when I'm looking at this problem, this right here is my M. Excuse me. This right here is my mass. Kilograms is a mass value. It's heated from, so that's my initial temperature, and 80 degrees will be my final temperature. They do give me the specific heat, this number right here, and that would be C. So if I take a look at my variables, I want to find Q when they give me M, T, and C. This is definitely a chance where I'm going to want to use Q equals MC delta T, or we like to refer as MCAT. All right, I want to solve for Q, so I'll put that there. Got to go back and find my mass. My mass is in kilograms. That's a good one to have it in. So we got that. They give me the C. That's awesome. That's a specific heat of water. I go back at the table and see it's in there. 4180 joules per kilogram per Kelvin. Now what's great about when I look at this is the kilograms are on top, kilograms are on bottom, so those two units cancel. Now if one was in grams, that'd be a problem. I'd have to solve that problem. But here my units are canceling, looking great. And then this part here is going to be my change in temperature. So change in temperature is always going to be the final minus the initial. So looking at my final temperature, that's 80. Minus my initial temperature, that's 25. Now I do have these in degrees Celsius, but that's okay because in my Kelvin, it's 1 degree per part. So this change in temperature is going to be the same whether I have it in Celsius or in Kelvin. I could take a moment and convert it into Kelvin, but because 1 degree Kelvin is 1 degree Celsius, I don't really need to go through that extra work. That part was seen in the video too that you watched online. So this difference between the two would be 55. Oh, no. Now that I've got those parts, I'm just going to put in my calculator 32 times 480 times 55, and I'll get a Q value. My Q came out to 7356800. That's what my calculator spit out. And so when I'm thinking about sig figs and rounding here, I'm going to go with 3. 7, 3, 6, 1, 2, 3, 4 zeros after that. I'm going to put that in scientific notation because that does look a little big. 1, 2, 3, 4, 5, 6. This is 7.36 times 10 to the 6th joules. If you got any questions, please put them in the Q&A. I'd be happy to answer anything you've got. Sometimes it takes some time where I do one, kind of show it to you, and then you give it a go for your next one. That's what I'm going to let you do here. Little brain break, though. Man, what if you would have picked the sandcastle one? Your sandcastle would have looked great. Look out for the waves, though. That could be a problem. You look great in that sandcastle. Why don't you give this problem a go? I'll start it in a minute if you need help. Notice I've got my answers here, so put your answers in the poll. That kind of tells me when you're done and how fast I should go. That way I kind of go at your speed. And it also gives you an option of D. So if you're thinking, I do not know how to do this, put D in there right now. That'll tell me I should start talking about it. So then I kind of like to do it this way. That way I know when they're getting done. I can know how fast or slow I need to go. Lots of times somebody will be putting in D, and so then I know when I need to talk. If somebody doesn't put D in for a while, then I kind of let it sit and let them think about it. That means they want to give it a go, and I'm totally on for that. And then once somebody puts in a D, I can start talking. But lots of times I'll kind of say, I'm going to start going on this. If you want to mute me, that's totally fine, because that way they can kind of work on their own problem and not get distracted by me. Yeah, so it kind of tells me how fast I need to go. And then once I'm doing the problems, if I start to see as I'm doing halfway through the problem, they all put in the answer, which happens to be B in this case, then I'll know, all right, got to move it along. Everyone's doing pretty good. It's my way of kind of judging how things go. Now I did a problem for you already, so I'm kind of just wanted to show you how I would tackle that part. I would kind of tackle this problem. The one that would be important about this problem is the idea that metal releases. So here I'd really want to focus on Q as negative. And so no matter if they all got that answer right, I'd always go back and actually have to tell them like, okay, here you probably just negated that whole negative number, but let's think back to what this releases mean and make sure I kind of talk about that part. So So I'm going to pretend that I did the problem and I'm going to move it along if that's okay. Nice job on your problem. Everybody mostly got B. It looks like there's no other questions to answer, so I'm going to kind of take you to the next phase here. Whew, little brain break though. What if you went fishing? I went fishing. I've never gone fishing in the ocean before. Has anybody? I have not, but I've seen them do it and it looks amazing. Their lines are like super long. I don't know how that works, but it looks awesome. So I want to give a little time if somebody like really picked fishing a lot, I could give them a chance to kind of talk about that. That also gives us a little brain break. And then I would move ourselves on to the breakout room. All right, we're moving to a breakout room. I'll put you in a breakout room. If you are a person who has some questions on this though, can you stick back? So put in the Q&A or write in the chat, whatever you're comfortable with, if everyone knows and stuff. Put in the idea, do you want to stay back here with me? I'll go through the problems with you. That'd be no problem. Or if you're not needing that, I'm gonna put everybody else in a breakout room. In the breakout room, you can write right on the screen and put in your answers for, oh, I started with number 2 here, sorry about that, 3 and 4. And down here, number 4, can somebody take the lead and show the work there, whoever feels really comfortable in your group? I'll be watching, you can see on my breakout screen here, I'm gonna be watching all of your slides so I can see when you're struggling or not. So if you need any help, you can always write help on your screen and I'll come into your breakout room. But I'll be watching and then moving in between them. So let's give that a go and I'll pull you back in when it looks like everyone's done. So that's kind of how I would end this section. They'd all go to the breakout room. I like to give an option for students. Lots of times people like don't really want to talk in the breakout room. I want to make this really a chance for them to do what however they learn best. So I want to give them a chance to stay back with me. They can do that one-on-one questions, especially for the shy students. So that works out really well. And then a lot of people just want to think it through on their own and not have to hear all the chatter of the breakout room or feel the pressure of saying something in the breakout room. So that's seeming to work out pretty good for me this year. And then, yeah, usually the person in the breakout room needs help. So I'm usually writing this out anyway for like the live video screen. But if I didn't, then I would kind of quickly do the problem and kind of write it all out if my person in the part knows how to do it. And then you would also be seeing on the screen, I would have like, if I have 4 breakout rooms, I'd have all 4 of the slides for each breakout room have their own slides so I could see it as it goes. And that way I can see, all right, they're getting the right answer. I know what breakout room to go to rather than just kind of moving myself along and kind of guessing what breakout room to go to. This way I really know which one because I'm watching their progress as they go. I think that's kind of the key of the breakout room. I get to see what their brain thinks. All right, that's kind of how I tackle this question or this topic.